Hey guys, it's me again, Linux Robot Geek, and this time we're going to use Golang to control a Raspberry Pi robot. First, I will go through the installation process of installing Go. Then we will talk about the Go package keylogger for keystrokes. And then we will talk about the Go RPIO library to control GPIO pins. And then we will look at the code and also look at the final code to control our robot. Let's get started. Welcome back. Before we can start programming, first we need to install Go. Now in my case, I already have Go installed. So if I go to my terminal, I type in Go version, it already has the version installed. Now to install it on your own PC, first you need to go to the downloads. So you can find the AMD 64 version. You can also find the ARM 64, the ARM v6, Windows. There's also FreeBSD and Macs. And that's it. So if we go to this page, first we install, which I've already done that. Then what you need to do is unzip the file, or in this case untar the file. Then you will need to move it to the user/local directory, and then you will have to add this line to your etc profile file. And the reason for that is this will not work if you log out or if you start up another terminal. You will have to make this permanent. So once you add this line, then you would run the command source/etc/profile. Once that's done, you can run Go version, and I've already run Go version for that. But that's pretty much it. Once it's installed, you can start programming. So let's start with the keylogger library. Now I already installed it on my own machine. So in this case, if we go under documents, I already have it here. So I'm going to show you how to run it. So we're going to go here. I'm going to open a terminal on this directory. So first we need to talk about this keylogger. Now as you can see here, we have the code. Now first thing you'll need to do is import package main. This is important for any Go code. Now TechWorld with Nana has a great Golang tutorial. It's a 3-hour tutorial, and I will link it below so you can get started. Then we need to import our packages, which in this case are the keylogger and a logres, which we will need to log. Then we have our main function. We have to find our keyboard device, so we define our keyboard here. Now if there's no keyboard, it will log no keyboard found. You will need to provide manual input path. And if it does find it, it will locate it at our keyboard variable. So in this case, it would be at dev/input. So let me show you. So if we go to x input, for example, see, mine is located at ID3. So it would be at /dev/events and then /3. So it'd be our ID. So that's important to find out. Make sure you have a keyboard connected. Then, of course, it will check for any errors. And then it will read any events. Then it will loop through the range of events. So in this case, I added some extra keys here. So if we press the key, and then, of course, it will tell us which keys were pressed. Now, in this case, we do up, down, left, or right. Then it will print up, down, left, or right. And if we release the key, it will press stop on here, and it will also tell us that the key was released. And then it will break once we exit. I should note that if we're going to run this, we need to run this as root. So I already built. Now you can do this by building it. Go build, which has already been built for us. So to run it, we do sudo dot example, and then I'm going to put in my password. And then, of course, it starts. And as you can see, we are now at event 3. So let me show you what happens. So we'll press up, down, left, Right. As you can see, the events have been read. So we have up, down, left, right, but we also have stop anytime we release the key. And this will be important, especially for our robot when we want to move the robot when the motors go up, and we stop the robot when the key is released. So we will exit with Control C. Now, the next piece of code we need to look at is the GPIO code, which is right here. So we'll go under examples, and we'll go under blinker, and we'll go here. And as you can see, we have our package. We also have the import packages with FMT. We have Go ARPIO v4 installed. We have OS and time. So we define our pin here, which is pin 10. Then we open our memory map for the GPIO to check for any errors. We unmap when we're done. This is necessary to close it properly. We set its output. And as you can see in this for loop, we blink the LED 20 times. And then we have our time.sleep, which is very similar to the sleep module on Python. However, we are not going to use this because we already have the code we're going to use here. So as we can see, we import package main. We have our imports here. We added our Go ARPIO v4. We have FMTOS and time. We define 5 pins. These are our motors here. And this is the I, which is GPIO 25. First, it will check for errors. Then it will close the memory when done. And then it sets all our pins to output. We blink our I LED 4 times. This is optional. This is not really necessary, but you can add this if you'd like. Then we define our keyboard as before. Then we define our key here once it's found. Then, of course, we read our events. Then we define everything. Then, of course, we have our functions on the way bottom. And, of course, we define our motors. We have forward, backward, left, and right, and stop. So when the key is pressed, we either go forward, backward, left, or right. And if our key is released, we stop. So that's it for the code. Let's get started moving Torvalds, and I'll see you after this. Welcome back. So this is the demo of Torvalds working with Golang. So as you can see, I have successfully got Torvalds to move using a keyboard. And in this case, I'm using my Bluetooth keyboard. So I can go forwards, backwards, right, and then left. And as you can see, it worked just fine. So I call that a major success. Now that we were able to control a robot using Golang, this opens up many possibilities in the future. In fact, in the next video, we are going to use web development to control our robot over a network. So, until then, see you next time.